Hi, everyone. Welcome to Cobots and Coffee. Thank you for joining us this week. Just a bit of housekeeping ahead of time. We are going to have a short Q&A session at the end of this, so if you do have any questions, there's a button up at the top that says Q&A. Please go ahead and type your questions in there, and then we will moderate at the end and get answered what we can. So with that, Alex Lee, our General Manager, go ahead.
Yeah, good afternoon, everybody. I am the General Manager of Doosan Robotics, if we have not met. Thank you for joining us today for Cobots and Coffee. I'm super excited today about this topic and also having a discussion here with Rohan, who has been around Cobots for quite some time. So his insight and everything, I'm looking forward to learning more about artificial intelligence and how it applies to collaborative robots and what we can look forward to. So give this opportunity to introduce Rohan. If you wanna introduce yourself and let people know a little bit about yourself, that'd be great.
Yeah, absolutely. Thank you. Thanks for the introduction, Alex, and thanks for having me. Good afternoon, everyone. Rohan Gaglani. I am the robotics product manager at GCG Automation. My journey with robots started back in college, where I studied mechanical engineering at Penn State and went on to work for a company which is now a distributor of Doosan in Pennsylvania. That's where I kind of learned the ropes of robotics, deployed about 5 to 6 systems with different cobots before RG Group picked up Doosan, and then went on to work for a competitor of Doosan's, and eventually ended up in some of the material handling spaces, again, in relation to robots, and now I'm here with GCG Automation. So I've had the opportunity to visit about 150 different customers, look at their deployments or look at their applications, look at what they're trying to do, look at their current form of functioning, the way they work today, and really try to understand, because the customers sometimes are not sure where to start, and so really try to understand what would be the right advice and recommendations to them. Recently, I'm also getting my MBA, and so as a part of that, we have a lot of AI stuff in our MBA program here at Ohio State, and that kind of gives me the ability to cross these two areas of knowledge that I've had the privilege to gain and think about it together. And so that's hopefully what we're going to be discussing today.
Awesome. Thanks for that background information. Today we're gonna talk about artificial intelligence, and it's certainly a topic that is really hot right now. I think a lot of us have in some way or another seen artificial intelligence in our lives, with the different tools and things like that we've seen. I know that I just saw a news article that said about 90% of the students in school have used ChatGPT as an example in some way or form for their schoolwork. It's just very interesting how this is evolving. But one of the areas that I noticed specifically in automation, it's not as widely used just yet. It doesn't seem like it's been implemented as deeply as it is in the commercial space, with what we've been seeing. So I'd love to pick your brain today, Rohan. So let's get started. I think I'd like to ask you the first question, which is, how do you foresee, and what do you foresee actually being the first area in manufacturing for artificial intelligence to be implemented?
Yeah, so I think there's a lot of low-hanging fruit applications that collaborative robots especially have been able to kind of uncover in the manufacturing world. So palletizing, machine tending, dispensing, welding, all these different packaging, all these different applications, have a really good use case for cobots even today. But I think some of the challenges are the fact that cobots don't really have that intelligence. You can program it, you can set up algorithms which can be as complicated as need be even today. But really, with AI coming in, we're going to have this ease of programming taken to a whole different level. And the concept is, if you talk about pallets, which is, one of the solutions that is provided by a partner of Doosan's that does palletizing. They have created some really good algorithms, some really good layers of software in between the robot and the application with the robot, which is palletizing. And they've taken care of a lot of nuances in the application, all the different issues, or a lot of different issues that can occur in the real world palletizing environment, and have made it easy to, reset any faults that may come up with, a box being a different size or a pallet being slightly broken, just two or three of the problems that may actually come up. And they've created some complicated algorithms to be able to take care of these issues. But even today, when we go into sites and we look at these applications, we're trying to make sure that every single problem that can come up in that environment will be taken care of by this algorithm. That may not always be practical and possible. What AI can do is, with its self-learning algorithms, it can start to tackle all these issues that are coming up in these environments and make it much easier to deploy these products. It can make it much easier for integrators, for distributors, even for end users to just say, okay, this is the application, this is what a human has been doing, and this is how we are going to, repurpose that human and then use a robot, to do this mundane task and help take over that problem. So just still a lot of the low-hanging fruit in manufacturing that can be captured by introducing AI with cobots and robotics in general.
Mm-hmm, mm-hmm. So I think it seems like the future of AI-driven cobots is inevitable. We're definitely heading in that path, and the whole concept of collaborative robots is it's collaboration with humans. Mm-hmm. So between the two technologies kind of developing together, how do you, or what is your recommendation for businesses and how they should adapt and maybe embrace this new paradigm?
Absolutely. So very recently I read this very interesting book called Power and Prediction. It is a fairly new book published in November 2022, if I'm not wrong. They really hone in and talk about new technology and mainly AI, and how they kind of draw an analogy to electricity when that was discovered and used in manufacturing spaces, and it was replacing steam that powered these plants. And so it really talks about three different kinds of implementations with new technology. There is the point implementation, which is you literally take something that's happening right now and it's, you're replacing it with this new technology at that very point. Then there's the second kind of implementation, which is an applications implementation, which is slightly more than a point implementation. You're changing a few more things. And I'll give you an example that the book used for electricity here in a second about these implementations. And then the last kind of implementation they talk about is a solution level implementation. So going back to our electricity analogy, a point implementation may just be taking one of those camshafts that is being powered by steam and replacing that one single camshaft with an electric motor. You're not changing anything else on the machine. The machine is still running as if it was a steam-powered machine, but the only thing you changed is the power source for that camshaft. The other option that you could actually have is to redesign that machine in some way, shape, or form, and take into account all the benefits that are provided by now having electricity available to us for the deployment and making the change accordingly. And this is slightly more than a point level solution. You're changing the application of it. You're changing how you're manufacturing the specific component to better work with the new power source. And then the last type of implementation is a solution level, which is factories today. I mean, each and every factory, you're not going to see a steam, power plant today. It's all powered by electricity. And that's basically where the solution level implementation comes in, is you're designing the factory around the fact that you have this new power source available, which is, you can turn it on and turn it off at any point, which you didn't have the ability with steam. You have this camshaft that is connected to all machines in the steam case, but with electricity, you can literally power it. You can position it anywhere. And you can have a lot of different types of machines in the same environment. So this analogy, even before we start talking about AI, is very applicable to robotics in general, because this has been, the complication and a very similar dynamic between us going in and trying to just do exactly what a human is doing versus the customer willing to be able to work with us and understand that this is a different technology. This is going to take more than just changing or just putting a robot in place of a human. It's going to take changes upstream and downstream of the robot to be able to give the most efficient and positive outcome for the customer. And so with AI, I think the point solution part of it is going to get much easier because now we're increasing the cognition of the robots. We're helping them become more human-like in some way, shape, or form. We're giving them the ability to think with these advanced algorithms and think to a certain level. Obviously, they can't really match the human mind, not at least for the next 5 to 10 years. But we're giving them that ability to take over some of these applications. You have a package coming down a line. It might be a few millimeters different in size as compared to what's programmed. This AI system would be able to comprehend that and understand what kind of adjustment needs to be made in that packaging line to still successfully package and not fall down. If there's a box which is slightly differently dimensioned, and I'm just trying to use an example in my head. I'm thinking about a bar of soap coming down a line, or lots of bars of soap coming down a conveyor line, and you have a robot that's picking up these soap bars and packaging them in a box, right? So all the different things that could be different in this case, the bar of soap could be slightly differently sized. It could come out, slightly angled. It might not come out perfectly. And we want robots that are able to kind of take care of these small things, that can go, I wouldn't say wrong, but different, and still be able to do the task without human intervention. And that's, I think, what AI is going to start helping here very soon.
Yeah, I mean, certainly AI in general is not only intriguing, but ultimately, I think, very, very cool. And as we combine that with collaborative robotics, definitely you just illustrated how it can enhance, flexibility. How about, just adaptability to existing production lines? It seems like, maybe you need to almost redesign everything, or do you have any examples where you can see this synergy between AI and collaborative robots just optimizing existing production efficiencies and maybe streamlining some operations?
Absolutely. Yeah. And again, going back to the point solution side of things, that's where AI is going to really help make a difference. When we talk about more the application implementation, obviously there's a lot of customers that are very open to these ideas. They're open to kind of redesigning their the production of a couple of different products, that may be changing down the road, or if something new is coming up where they need to make adjustments to the product line. They're more than happy to get into this applications solution type of implementation where we're not merely just taking the spot of a person, but we're designing the system to take care of the different variables that are in play when you use a robot. The different limitations, the different upsides of using a robot are being taken into account when designing the whole system. But even for some one-to-one replacements where we are just having a huge labor shortage, or this job is too dull, dirty, or dangerous, and you want to have a robot do this thing or do this job, you go in and you look at the current complexity of the process. It's designed around a human, and like I said, the upstream or the downstream process is just not sufficient, or is not good enough sometimes for a robot to be able to take that on. And AI can really help with that. But there is a lot of applications even today that are really low hanging that we're able to automate without any difficulty. So it's just going to bridge that gap. It's going to break down that barrier even further. And if we're able to implement robots in 50% of the applications that we see today, for example, we would be able to do that in 75 to 80% of the applications more easily.
Wonderful. So now I'm going to ask you to look in your crystal ball for a minute here and kind of give us an idea of what we can expect in the next 5 to 10 years. What type of game-changing advancements can we expect?
Absolutely. And I think, companies like Doosan Robotics coming in is definitely helping us revolutionize this industry. One of the main reasons being the fact that, it's democratizing robots in terms of cost. Doosan is really working very, very strong and very hard on understanding what one of the biggest barriers it is, and one of them is cost. And so bringing the cost down of the robots themselves lets there be more room in terms of customers being able to get a good return on investment for the application, because say the robot costs X amount and you want to add some solution, or you want to add some solution application capabilities to it, that costs money, right? And so the fact that the robot costs are coming down, that's definitely going to help more implementation. Now, going directly to your question, Alex, one of the other really good things that is happening in the industry is the fact that people are really understanding the value of automation. There was just not enough incentive, pre-COVID, especially for manufacturers, or manufacturers didn't really capture that incentive that they had, didn't really understand, things were going status quo, things were just working out. And after the whole labor shortage thing happened and, people couldn't go out to work, I think manufacturers have started to understand that, it's their Achilles heel. I mean, if they can't find people to start doing things, how are they going to keep their lights on? And I think that's really helping incentivize manufacturers to consider this automation, consider go into this force and start working towards it. The other thing, a lot of software workforce is now getting diverted towards manufacturing. You may have heard of these recent incidences with some of these big software giants where, they had to lay people off and reduce their workforce. And all this really bright talent is now getting into these different sections of software implementations where it's been really, really dry. I mean, if you look at some of the older robot manufacturers, you'll notice that they use very traditional programming languages. Everything feels ancient in a way. And you're now starting to see a lot of solutions are more computer-based. People are starting to understand that PLCs are not the only way of controlling equipment. We can start working on computers. We can start using Python and these other programming languages, which again, Doosan has, done a really good job with ROS and stuff like that. So just having everybody's focus, or a lot of focus, starting to turn into this direction is definitely going to help, because automation has a lot of catching up to do when it comes to software, and with this new incentive coming in, I think people are going to be more interested or there's going to be a lot more interest and a lot more new things coming out in the industry that's going to reduce these barriers to automation. The other section that's kind of overlooked is the service side of robots. You see manufacturing as always being the focal point. And if you look at statistics right now, about 90% of the robots, 80 to 90% of the robots are deployed in manufacturing environments. So, Doosan's brand idea of trying to or wanting to also support those, service industries and other industries that are not necessarily manufacturing related is also great. I mean, obviously, Doosan does a great job in manufacturing, but there's just so much other potential and so many other spaces that, robots could be deployed into, specifically the service industry. And I think that's going to start taking off here very soon as well.
So it's interesting. We started talking a little bit about the implementation of AI-driven cobots in manufacturing. Now you mentioned a little bit about the service industry. I guess my next question for you really is, maybe it's application or different industries or sectors. Where do you see, the most benefit from this, convergence of technology between artificial intelligence and collaborative robots? Who's going to benefit the most, do you believe? What industry or maybe what application?
Yeah, I think one of the biggest industries that is going to see a lot of value is the food industry. And, Doosan's recent move with creating the first food-grade collaborative robot on the market, I think that was just brilliant in that regard, because if you just look at these different restaurants, these different chain restaurants that are out there, you look at McDonald's, Wendy's, you name it, they're starting to face labor challenges. There is just not enough workforce available to start doing those jobs. And they have a very high incentive of, a very high need for automation. And there is, companies taking note of this fact. There's startups, there's individuals out in Silicon Valley, you look at sales.robotics, Robotics, you look at a few different companies that are really pushing on getting out there and starting to cater to these industries. So that's definitely one. The other industry that I can think about is just, the cleaning industry. There's now robots that are doing, window cleanings in big skyscrapers. There's products out for that. If you just look at different toilets in different locations, cleaning those is by no means a fun job for anybody, and there's so much potential for robots starting to take those over. And you don't necessarily have to worry about high levels of repeatability. You don't have to worry about, all those things in these aspects. You still need a decent amount of repeatability, but, it's not as cutthroat as a manufacturing environment where you need 99.98% efficiency, or you start losing, hundreds of thousands of dollars per hour. So that can be considered a low-hanging fruit. And with AI coming in, I think making the software and the programming side of things easier and more algorithm-based, more self-generating, rather than something that a person has to constantly go in and hard code. That is going to really start helping change these dynamics in the near future.
Awesome. Yeah, we had interesting meeting today here at our office, and this is a large chicken fast food chain, and they made a comment to us because we were just showing them how we can fry chicken with our robots. But they said, "Have you ever thought about what you do after you fry the chicken?" And I said, "What do you mean?" And he said, "Do you have robots that can put the order together, assemble the order together?" So that and that seems to be a big hot topic for them, an area that I didn't even really consider at this point because we were thinking about just the back end where it's just a repetitive job. This one is repetitive, but it also requires every order to be unique. And so this is where I think that AI, to your point, these restaurants and service sectors are all going to benefit from some AI driven collaborative robots. So my last question for you, though, is, just what, I guess, advice for everybody that's on this call, and how do we go from here is the question. So there's some, significant challenges, obviously, ahead of us. And it's certainly something that we need to be better prepared for in terms of how this technology gets implemented with our collaborative robots. So, what do you think are these challenges that we should be aware of that needs to be overcome in order for us to unleash the full potential of these AI-powered collaborative robots?
Yeah. So I think AI is going to be very paramount in kind of taking us from where we are today to a point where people are comfortable doing more application implementations and solution level implementations. I don't know, it was very recently in the news, a large tool maker tried to create a factory which was highly automated. They created a factory from scratch in Texas, and I think it started in 2021, and they had to shut it down because it just wasn't, up to the mark. So it was very interesting because, they jumped to that level where we're talking about a solution implementation and tried to maybe hasten it. Maybe didn't just have the right set of people, right set of robots to do what they do. But what customers need today is a very step-by-step approach. They want to start at that point solution level. They want to be able to deploy robots for a few things that are really problematic, or really some places where they can't find labor. The 3D dull, dirty, dangerous is to a different level there, and they really want to be able to use a robot in that place, but they can't because of their current return on investment challenges. That they look at the application and it has just so many different variables that programming that would be very complicated, or you would just have such a high investment in the peripherals to make that work. The robot is not the bottleneck, it's the peripherals. It's everything that needs to go around it that needs to do a good job for the robot to be able to do what it does best, which is the same thing again and again. And AI is going to come in and help it not do the same thing again and again. It can do a slightly different thing when it needs to do a slightly different thing. And I think that's where the main value of AI is going to start coming in, is now you go in, you look at this application and you start saying, okay, there is 5 different things or 20 different things that can happen. And every now and then there's these other things that can happen. But with self-learning algorithms, this robot is going to be able to tackle these problems down the road. Let's monitor it for 30 days after deployment. Let's train it. Let's tell it what the right thing to do is. Let's educate its prediction algorithm to be at a point where it really understands what we say is right and what we say is wrong. And it's going to now use this data that we provided it with and create and be able to work with everything in the future. It might see a whole different challenge in the future, but it at least knows what a human thought process is, what is, what a human says is right and what a human says is wrong. And it's going to try to adapt that and learn, by itself based on that. Mm-hmm. So I think that's a really good starting point. I mean, PALs, just going back to them, they can definitely consider start, and I've had those discussions with them. I mean, they talked about kind of implementing some AI algorithms into their palletizing software. Mm. So if whatever challenges that they're still seeing every now and then where they don't think their solution is a right fit, they're really looking at AI to be the one that is going to start fixing those problems for them and increasing the places where they can deploy their solution. So really, I mean, working algorithms are everywhere. A lot of companies around the world have developed a lot of different really good algorithms. I mean, if you look at Apera AI, they're doing a really good job. It's also a Doosan partner, doing a really good job in helping bin picking and vision systems with the help of AI. And so just taking it one step forward, increasing the heat up a notch, increasing the intensity of those algorithms and the intelligence of them is, I think, that the next best step towards getting there, because we can't just go from 0 to 100. We have to go slow. We have to go step by step. And there's very clear, very good ways of doing it. And some of these companies that have experience with the algorithms and deploying them already know, where they need to be going with this.
Mm-hmm. Awesome. Yeah, I really appreciate your insight on this. I know that there's still some challenges along the way, but it truly is exciting to see where we're headed. I think there's going to be a lot of new applications developed because of these AI-driven cobots. And yeah, love to be working with some of you folks on here with Rohan and tackle these challenges that are in front of us. And looking forward to it. So I'll turn it over to Stephanie and see if there's any questions.
Yeah, great. We do actually have a couple of questions. Again, I just want to call out that over to the side, at the top panel there's a button that says Q&A. Please feel free to post any questions in there, but we do have a couple right now. The first one is, with the majority of AI processing being performed in the cloud, how do you see the industry incorporating AI into systems that are mostly offline?
Yeah, and I think that is a great question. And I think one of the best examples of how a company that's tackling this really well is Apera AI. So what they do is they have GPUs located in their facility that are, they talk about their cybersecurity for their GPUs and everything that they're able to do with them. And what they do is they take on the part training. They take on the training for you at this point. So you are now sending them pictures of the parts. You're sending them some CAD files, and they'll run the training for you. You can send them to a secure server, run the training for you, and then they'll send you a confirmation of the deletion of all these things off their server. So after the training is done, the model is stored in a file that's sent back to you that you can upload into your Apera bin picking system, and you're bin picking at that point. So there is a few different methods that this could be done with. They have a physical, system where they're running this, but I think on the other hand, there's just so much development going on in the cybersecurity space as well, because this is very well understood by everybody, by all the different organizations, that this is a real challenge. You need to have cloud computing power to be able to train models and algorithms and run AI successfully. So lots of work going on in that regard, and a lot of customers are now opening up to the ideas. They have some really intelligent cybersecurity people as well, and users who are really understanding what they're starting to have. These people now who are really understanding what needs to be done to successfully be able to have work with AI companies like this. And the reason being, it's the need of the hour. This is what is required. There's a lot of incentive for companies to start pushing in this direction. And so now they're looking for solutions rather than actually focusing just on the problem.
Great, thank you. And we have one more question. Do you see AI making a significant impact in robotic system design?
Absolutely. Yeah, that's another space where I would have loved to have more time to touch on. But really, if you think about it, one of the biggest challenges when selling a robot solution is the quoting phase, is really understanding the customer's problem, understanding what we're trying to tackle, and as a solutions engineer, you go in and you look at everything upstream, and you have to look at everything downstream to make sure that that thing that you're solving is going to work with everything that's existing today. If not, you have a lot of back and forth with the customer to discuss alternatives to that upstream thing or to that downstream thing, and see if those could be changed. So there's a lot of back and forth, a lot of redesign work, and for the most part, it's not paid for by anybody. This is just inefficiency in the current process of designing. And I think with AI coming in, the quotation tools can start getting much better and much more mature. And you can start having this new technology that's helping you quote better just based on past experiences and older projects. Right now, past experiences live with the people. You can have the best documentation in the world, but it's, whatever the person knows is what the person knows. Whoever's done these projects in the past is going to be able to kind of relate, remember, and, adapt accordingly. Some of the most successful integrators, if you look at today, are ones that are kind of doing the same thing again. They're kind of almost becoming OEMs. Again, Pals comes to mind. They're focused on palletizing, and they're really trying to do the best they can there. But all these custom solution integrators, that's one of the biggest challenges, is just getting stuck in the quoting phase. So with AI, I think there's just so much potential and so much opportunity to learn and understand past quotes, past processes that were quoted, and how they correlate to this new process that came in. And if there is any correlation or anything that can simplify this whole process, of putting a quote together and sending it out to the customer.
Great. Awesome. Thank you. If there aren't any other questions, it looks like there are not. We will go ahead and wrap this up. So thank you, Rohan, so much for your expertise and for your time. We really appreciate it. Alex, thank you as well for your time and your expertise. And thank you, everyone, for joining us for Cobots and Coffee. We hope that you have a wonderful Thursday, and we'll see you next time.